as I told you in the email, this one is already covered by Soonhung last time, so I'll be quickly cover. So we are covering two, 3, and so how can we represent designs and the knowledge, especially the special relationship and intention. So form and special relationship, that is key items for engineers: shape, space, form. Right? So how can we? And then there is a topic on geometry and topology. So topology is about kind of relationship or neighboring information. Who are next to you, next door? Neighbors. Who is neighbors? And geometry is kind of dimension. So you can separate out. For defining a shape, you can separate out into topology and geometry. And composite item, this is about architectural viewpoint, because the author of the book is coming from architectural department. And coordinate and properties of shape. So this is about topology. Right? So each grid has their neighboring colors. Right? When you bend, the shape is changing. Right? We said geometry is changing, the dimension is changing, angle is changing. Right? But neighborhood information is same. Right? Neighborhood information is same. We said topology is same, no change on topology. But when the bending is extreme, some point it can break. Right? Then topology change. So you can find out the difference between topology and geometry. That is an important idea in mathematics. Right? It's ideas. And topology and morphing, you can think about, is it same topology or same geometry, or only change of geometry, or including topological changes? There are topics. So morphing from Wiki, morphing is a special effect in motion pictures, films, animations that changes one image or one shape. Image means usually 2D, and this is usually 3D shape, into another through a seamless transition. So usually they are find out some feature point. We said corresponding point or feature point, important point, corresponding important point, and then connecting them, and then you can find out some interpolation sometimes, right? Interpolation. There are more technical method to make a more smooth and transition. Right? Anyway, the baseline idea is finding out corresponding points and then move one by one by interpolation. So there are some samples. So, morphing. Okay. Car can be changed into tiger. People are changing from. Level of abstraction. So level of abstraction. Abstraction is, you said, once again, the hierarchy of object-oriented programming, class hierarchy, class instance hierarchy, or instance. So we said it's more general, or abstract, right? This is more specific. So level of abstraction is going up as class is going up. And so each design, say smartphone or car, can be represented inside the computer in different level of details. Then it comes with redundancy problems, because same one described multiple times. Anyway, there you say once again the topology and geometry is an important step. So in the level, they are talking about form specification. That is only written language sentences. And flow plan, that shows only rough sketch of relationship. And then finally, this one is good enough to make the product. So each includes dimensions, thickness altogether, distance. Right? The engineering drawing can be in this level. Right? So it can be delivered to the shop floor to make the product. But we start from the ideas, the requirement specification in the top level. Right? This shows also, Sunjo shows better images. Right? You can find out which one is rough or which one is detailed. Also the Google and then design intention, the requirement or goal hierarchies, objectives, similar wording. So design description is we are doing explicit, implicit, and derived. Implicit properties are derived from them, and also there is redundancy problems. That is, consistency and redundancy is very important topic in database management system. If you go to the computer science department, taking a course on DB, then you can learn more about redundancy and consistency. And this one shows some relations or comparison between knowledge base system and database management system. So main storage inside the content can be in data, corresponding in knowledge base in knowledge, and items can be, and algorithms you can use data for manipulating data. Right? Nowadays, the big data is important. Right? Big data is very similar to database management. You need to have some more AI to handle big data. Right? That is coming similar to here. Right? Reasoning, controlling, and inference engines. Anyway, in database management system or knowledge-based management system, consistency and duplication is an important topic. Goal hierarchy, goal decomposition. So at the beginning, the goal is very simple. I want to go to the Busan today. Right? And then what? What should I do? Then I can divide the goal into sub-items, sub-topics, sub-activities. Right? I should leave the room first. Right? take a taxi and they go get to the train station, buy ticket, something like that. So you can divide into small items incrementally. So you need to sub-goals. It can be very similar to this hierarchy, right? Sub-goals. And then sub-goals can be interact each other, right? This one, what is the relationship between two sub-goals? Is it clearly divided, or there are some small relationship? So separation, not always possible. Right? Separation. Separating my goal into sub-goals. Right? For the going to the Busan is relatively simpler to divide into small topics. Right? But in nature, it is not simple. They are goals are interpretation sometimes. So we call this intended interpretation, intended objective. So it comes with a chicken and egg game. There is a special topic area, a subject area, or academic world. There is a configuration design. That is very similar to you. If you want to build your own PC, then you select your parts coming from catalog, right? Internet shopping you can do, right? But you should select proper combination of parts to arrive at nice PC for you, based on your budget, right? So you're doing something, right? That is very similar to configuration, configuring existing parts. So this is a hierarchy of goals and sub-goals. Portable means light and compact and has a handle. Right. Compact means can be simple in profile and no sharp projections. And simple profile can be a cube or pyramid or sphere. So you can arrive at the leaf node where you cannot divide no more. Right? So to make a bottle, you can arrive at composition or sub-assembly, say sub-assembly or parts. So a car can be divided into, say, 20,000 parts, like this one, assembly. Or how about airplane? How about ship? Or ocean plant. There is more parts there. Or how about nuclear power plant? How many parts are there? I found that 200,000. But it is depending on your system or your management system. Right? As I told you that how much you divide them and manage and separately. Right? So comparing to 10 years ago, the number is increasing because you have a computer system, you have more detailed tools for managing such small pieces. Goals and objectives, design is better than the other one by comparing their performances. Sometimes it can be cost or maintenance, operational maintenance, or performance characteristics. So we call this is evaluation. So I ask you to design a smartphone for Indian ladies. Everybody has his own design output. Then we can do some evaluation to find out the best one, right? Evaluation. But every time it is not easy to find out the solution which fulfills all the requirements. And this may be my final slide coming from myself. So goals also changes. Right? especially sometimes I found that in a big project, say, in my experience that the Navy battleship, because they say it takes several years to design and also several years to build. Right? During that time, the Navy who ordered the ship, they changed their mind. Also, there are cases where there comes a new missiles, new radar system, and also an enemy country has new battleship, something like that. So it's a changing, right? So that they change their mind. Say during construction, they change their mind. So they change the design. They select a new equipment, new missile. Right? It happens. So goals they change. So we need to have a requirement management system. I told you that this idea is coming from nuclear power plant. That is also changing. Say Fukushima, there is some explosion from Japan Fukushima plant. After that, the whole nuclear community changed their rules. The regulation level is higher for safety level because of they did not expect such a tsunami coming into the nuclear power plant, so that they are not prepared from the beginning, from the design stage. That kind of situation is not prepared. So now they change the regulation or safety level so that during the construction they change. Goal is a product of design process. So as you go on to designing, and then goal is also more clarified. See, I want to design a good smartphone for Indian ladies, young ladies. That is very rough idea, right? But as I go on to surveying and gathering information, the goal is more clearly defined. Right? As a book, sometimes, right? As a drawing. Description of design. At the beginning, it is incomplete and uncertain. But final stage it should be. All right. Question? No question. Very clear. We did it twice time. Same topic. 동작